The question says that to maintain a rotor at uniform angular speed of 200 radians per second, an engine needs to transmit a torque of 180 Newton meter. What is the power required by the engine? So we have also need to assume that the engine is operating at 100% efficiency, and non-uniform angular velocity is the absence of friction implies zero torque. In practice, applied torque is needed to counter the frictional torque. So there is a motor running at uniform angular speed of 200 radians. So let us assume that there is a motor. This is the motor, and this is the engine that is making this motor rotate. Now this motor is rotating at an angular speed of 200 radians. So omega for this motor is 200 radians per second. Now this must be connected with some belt drive or something like that, or there is no any coupling mechanism that is being shown over here. We have to assume that there is no any energy loss, that is the engine is operating at 100% efficiency and there is no any friction. So at what power should the engine be running so that this motor would be rotating with the angular speed of 200 radians per second? Now we have been given that engine needs to transmit the torque of 180 Newton meter. So power is equals to torque multiplied with the angular speed. Now if we want to relate it with the linear motion, then we know that power is equals to work done per unit time. Now work done is equals to the energy joule, or joule is equals to force times ds by dt by time. So here F dot ds is the work done, and when this work done with respect to time, then we say that it is power. Now similarly, tau here is the analogous to force, and ds by dt is the linear velocity, and in angular sense we can say it as the angular speed. Now torque is given as 180 Newton meter, so 180 is here, and omega that we need to maintain is 200 radians per second. So omega is 200 radians per second. So if we take the product, we will get the power, that is 36,000 watts or 36 kilowatt. And since the engine is operating at 100% efficiency, so there is no any loss of energy. So we need the power of 36 kilowatt for the engine to be operating so that the motor can maintain its uniform angular speed of 200 radians per second. Thank you.